Hi, in this example, we're going to solve for x in a logarithmic equation using techniques from solving quadratics. So this one we're going to see is a little bit different than what we're used to, just because it's not easily factorable when we get to the quadratic equation part. So let's just go ahead and start by writing out the problem on the side. We have a log base 5 of x plus log base 5 of x plus 1 equal to 5. And we always want to write on the side to always remember the domain of logs. Remember that x can only be positive numbers when it's the argument of the log. So when we have log base 5 of x, this means that this x value has to be positive. So again, if we in the end get something negative, we have to go back and check our work or only take the values that are positive. Okay, back to the problem. Now we know that we see the addition between two logs with the same base. We can go ahead and use the product property of logarithms and contract these logs as log base 5 of, in this case, x times x plus 1 equal to 5. And I'm just going to simplify what's in the parentheses as x squared plus x equal to 5. Great. Now notice that we have the log part isolated on one side, and with only one log, right? So this means we can go ahead and apply the definition and rewrite in exponential form. And remember what that means. That means that we're going to use a base of 5, an exponent of 5, and the value will be the argument of the log, which is x squared plus x. So the base 5 comes from the base of the log. The exponent 5 comes from the 5 on the right side of the equal sign. And then the value comes from the argument of the log. So when we rewrite this, we're going to write it with a base 5 to an exponent of 5 equal to the value x squared plus x. Great. And 5 to the 5th power is 3,125 equal to x squared plus x. Now we get a familiar intuition here because we see this x squared term, right? We know that this has to be quadratic, and we start putting in our quadratic hat. And we're like, ooh, we got to get 0 on one side. So let's go ahead and move the 3,125 over to the right side and get 0 equal to x squared plus x minus 3,125. Now, there are no two values of 3,125 such that when I multiply them, I get negative of that number, and when I add them, I get positive 1. So there are 3 solving methods to quadratics, right, to solve quads. The first one we learned way back in the day was factoring, and we love when we can factor, but in this case we cannot factor, so you're like, ugh. The other one is completing the square, which, we use if we want to, but really we say when all else fails, use the quadratic formula. So we can complete the square here, but it's gonna get kind of messy, so I believe we should probably use the quadratic formula. And we'll use the quadratic formula such that a is equal to 1, b is equal to 1, and then c is equal to negative 3,125. So let's go ahead and solve this. We get x equal to, so I'll say QF for quadratic formula. So x here will equal negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this ends up becoming x equal negative 1 plus or minus square root of 1 squared minus 4 times 1 times negative 3,125 over 2 times 1. Great. Moving on, I'll get negative 1 plus or minus and square root of, and I just want you to notice that, yeah, we have 1. Don't be alarmed, this won't be complex because remember we have minus 4 times minus 3,125, which means it's just an addition. So if you just put in your calculator, 1 squared minus 4 times 1 times negative 3,125, you'll get 12,501. All over 2. This doesn't want exact values, so I'm going to go ahead and leave it like that. And I'm going to go ahead and remind myself the domain of logs. So, when we get plus and minus here, right, our brain should start thinking about, I need to make sure that all these values are in the domain, right? And I know the domain means all positive numbers. So let me put this in my calculator for the plus and then another one for the minus, and then I'll go ahead and omit the one that's negative, and if they're both positive, then I take both values. Put that in here. So I have negative 1, so put parentheses for my numerator, negative 1 plus square root of 12,501 parenthesis divided by 2, and notice that gives me a positive value. So let me go ahead and put in the same thing and put parentheses negative 1 minus, so now we'll do the subtraction, square root of 12,501, close the numerator, divided by 2. So I'm using Desmos here, so it can kind of, as I enter it, gives me a nice little prompt of what it looks like and what I'm actually entering. So I really do like this. It's a free online calculator, and the link is in our class sites folder in the homepage of our mom course. Okay, back to the problem. We can see that when I put in the minus 1 of this solution, I notice I get negative 56. So because of the domain of logs and my numbers always have to be positive, I'm going to go ahead and omit this negative value from my solution set and only keep the positive one. So let me go back to the problem and say x on the negative. So over here I'll put therefore x is just equal to the negative 1 plus the square root of 12,501 over 2, which means that it's approximately 55.40. And then notice that that is the answer that is in the problem.